Hi guys, I'm John Keller and I'm going to be presenting on the topic of precision viticulture today. Specifically what it is, what are the motives, what is the approach, and what are some specific components. I'll then talk about how it is helpful in a business setting, why it is the future of agriculture, and finally, where it's headed. A little bit about myself and why this topic sparked my interest. I spent time working in the wine industry and continue to do so today. It has been a perfect blend of my scientific and artistic backgrounds. I currently produce wine and have ever since I moved back from California. And I'm looking to expand operations this year and bring the historical hands-off approach to winemaking to the Cincinnati region. Many of you may be aware that Cincinnati is considered the birthplace of American winemaking during the 1800s. So, why do we need precision viticulture? Precision viticulture is all about identifying and managing variability within vineyards, optimizing vineyard performance, and in particular, maximizing grape yield and quality while minimizing environmental impacts and risk. What does precision viticulture consist of? It is accomplished by measuring local variation and factors that influence grape yield and quality, such as soil, topography, microclimate, vine health, etc., and applying appropriate viticulture management practices. Precision viticulture is based on the premise that high in-field variability of factors that affect vine growth and grape ripening warrants intensive management customized according to particular local conditions. As an introduction summary, precision viticulture is considered to be an approach to wine production based on recognition of the fact that the productivity of vineyards and individual blocks within a vineyard can be inherently variable over a space of time because of differences in topography, soils, soil moisture, slope and aspect, plant health and vigor, and microclimate and management practices. There are four major components of technology used for precision viticulture management practices. They are global positioning systems, remote sensing, geographical information systems, and variable rate applications. The global positioning system is a satellite constellation used at a georeferenced, spatially referenced vineyard data, such as soil samples, yields, etc., or some other grapevine management practice within the vineyard block. Geographic information system enables the convenient capture, storage, manipulation, and management of spatially aligned geographic data layers. Remote sensing refers to the capture of digital imagery of the Earth's surface by either aircraft or satellite. And then variable rate application describes any technology which enables growers to vary the rate of inputs. For the purpose of this presentation, I'm going to focus on remote sensing due to the fact that it's replacing manned aircraft monitoring with drones. Remote sensing is the science of obtaining and interpreting information from a distance using sensors that are not in physical contact with an object being observed. The science of remote sensing includes satellites, light aircraft, drones, and ground-based monitoring systems. Remote sensing is usually restricted to methods that detect and measure electromagnetic energy, including visible and non-invisible radiation that interact with the surface materials and the atmosphere. Unmanned aerial vehicles, commonly known as drones, are emerging as a cost-effective way to collect data with many advantages over the other traditional forms. Unmanned aerial vehicles are, as the name suggests, an unmanned vehicle which flies over the vineyard to collect data. The drones are good at monitoring crops for a very low relative price. When compared with satellites or manned planes and helicopters, low-cost drones are cheaper and can be deployed every day, even in a cloudy day. These machines are generally compact, can be cheap, mechanically simple, and are on their way to being easy to operate with advanced autopilot systems. Here's an example of some drone footage shot at one of my favorite wineries, Dirty and Rowdy, one of their vineyards out here. It kind of gives you an idea of the angles they take, how it can be useful in scouting, maybe potential planting, during harvest. So with any new technology, we have to consider regulations. The Federal Aviation Administration regulates the use of all UAVs. The FAA announced in February of 2015 the long-awaited notice of proposed rulemaking for UAVs. Under the new FAA proposal, drones that weigh less than 55 pounds will be able to fly up to 500 feet above the ground at speeds of 100 miles an hour. Remote sensing images are generally processed to produce vegetative indices, such as normalized difference vegetation index, which is also called NDVI, or plant cell density, also known as PCD. These are produced on a per pixel basis. These indices are often used as an estimate of vine vigor. In viticulture, vigor generally refers to the vine or shoot growth rate, whereas in remote sensing, vigor is used as a combination of plant biomass, so vine size, and in photosynthetic activity terms, the photosynthetically active biomass, which is also known as PAB. These indices computed from remote sensing are related to vigor. On the right here is an actual example of a normalized difference vegetation index produced from actual vineyard. It's almost like a heat map with the color changes, the color differences resulting in a broadcasting of difference in vigor. So as a winemaker, as a vineyard manager, you can use these figures to kind of realize what you need to focus on, maybe what crop goes into what blend per se. So you have like a premier crop, you have a lower tier crop, what gets blended away, what to work on next year, things of that example. And here we have a plant cell density example. I'd almost prefer this one over the previous, just due to the cleanliness of it. So you can see up top, it's almost like the raw image of it. Red indicates low vigor, the dark blue indicates high vigor, and then they kind of translate that down onto the actual vineyard map so you can get a real clue of what's going on. Same decisions are made based off of this reading, but it's just a good example to see both. So now that we have the data, what are the post-collection applications? You have canopy and vigor monitoring, crop load management, berry quality sampling, harvest planning, disease management, environmental monitoring, and then planting vines, scouting vineyards, and yield monitoring. It's useful in all aspects here, currently future planning, and also you can make decisions off your current scenarios. As a business, this can maximize profit because now you know what crop to use for your premier product, what crop to use for a blended away product, where to plant new vines, what vines to plant in these locations, how you predict for them to behave. There's just limitless opportunities in this new technology. Looking ahead, drones are starting to be used in other agricultural and mining settings in order to geographically map out future products or resources. One thing that we should keep our eyes on is the constant updating of regulations of drone use. Will they expand capabilities or restrict capabilities? And lastly, how do you feel about drones being used as data collection agents? Do you believe that drones should be restricted when it comes to personal use? I'm curious to hear your guys' thoughts, so please broadcast those when you comment on this video. I want to thank you guys for joining me and watching this presentation. I hope you're all having a great week, and I'm looking forward to seeing what you guys have to say, hear some of your ideas, and discussing with you. Thanks, guys.